Today we will see shortage of first preemptive scheduling algorithm. In the last video lecture we have seen shortage of first non-preemptive scheduling algorithm. So let's begin. So some of the key points about shortage of first. The first point is that it is also known as shortest remaining time first algorithm. Here in shortage of first, while a process is running, if another process with lower burst time arrives, then it will preempt the currently running process. That is, if a process is running, for example P1, and there is another process P2 with burst time lower than the burst time of the currently running process P1, then P2 will preempt, that is P2 will interrupt P1 and P2 will be given the chance to execute in the CPU. The third point, whenever a new process arrives, check whether its burst time is less than the remaining burst of currently running process. That is, at any particular point of time or in a particular clock, we have to see or compare all the processes and their burst time. So in clock cycle 0 we will see all the processes that arrives in clock cycle 0 and their burst time. In clock cycle 1, clock cycle 2, clock cycle 3, in each of the clock cycle we will see all the available processes in the system and their burst time, and the process which is having the lowest burst time will be executed next. To understand the concept, let us look at one example. So in this example we see that there are 5 processes, their burst time and the arrival time. So we start with clock cycle 0. In clock cycle 0 we see that only one process, that is process P4, is there in the system. There is no other process, so P4 is given the CPU. Now P4 will execute for one clock cycle. So because P4 is executing for one clock cycle, so that is why we subtracted 1 from 3, that is it is already executed for one clock cycle, so left is 2 clock cycle for P4. But in the meantime we see that in clock cycle 1 there is a new process P3, new process P3. Now P3 needs 8 clock cycle, P4 which is already in execution needs 2 clock cycle, so there is a comparison between P3 and P4. So what we are doing, because this is a preemptive, in each clock cycle there will be a comparison of all the available process in the system. So there is a comparison between P3 and P4, because in clock cycle 0 we have P4 arrived, in clock cycle 1 we have P3. So between P3 and P4 in clock cycle 1 we see that 2 is the smallest between 8 and 2, so P4 will execute for one more clock cycle. Now in clock cycle 2 we see that there is a new process P1. In clock cycle 2 we have new process P1. Now we have 3 processes in the system, P4 which is in execution, P1 the new process, and P3 also the new process. Now we have to do a comparison between P1, P3 and P4. Now P4 has already executed for 2 clock cycle. If you see, we are in clock cycle 2, so from 3 we have already executed for 2 clock cycles, so whatever is left, that is 1 clock cycle for P4. P4 needs 1 clock cycle to complete its execution because it has already executed for 2 clock cycles, already executed. Now if we have to compare between P1, P3 and P4, we see that P1 needs 6, P3 needs 8 and P4 needs 1. So between 6, 8 and 1, the smallest being 1, so P4 will continue its execution. Now because it needs 3 clock cycle, P4 it has completed its execution. Now we have to decide between P3 and P1. as there is no more process in clock cycle 3, we are not considering any more process. So now is the time to decide between P3 and P1. So between P3 and P1, which one is smallest? P3 is 8, P1 is 6, so P1 is put in the CPU. P1, 6 and 8, P1 is put in the CPU. Now this is executed for one clock cycle. So because it is executed for one clock cycle, remaining time is 6 minus 1, that is 5 for P1. Now in clock cycle 4, we see that a new process P5 arrives. Clock cycle 4, new process P5. Now we have P1 in execution, P3 available and P5 also available. And now what we have to see? We have to see that between P1, P3 and P5, which has the smallest job. So if you have to check, P1 requires 5, P3 requires 8 and P5 requires 4. So between 5, 8 and 4, 4 is the smallest. So what we will do? We will put P5 in the CPU. We will take P1 out, which will continue for one clock cycle, then we will take it out, that is it is executed for one clock cycle, and then we will put P5. So P5 is put in the CPU. Because P1 is already executed for one clock cycle, we have subtracted 1. Now in clock cycle 5, we see that a new process P2 arrives. New process P2 arrives in clock cycle 5. So we have P2. Now again the same process is repeated, that is in each of the clock cycle we have to see that which among the available process has smallest burst time. So we see that between P5, which is already executing, P1, P3 and P2, the smallest is P1 requires 5, P3 requires 8, P2 requires 2 and P5, because it has already executed for one clock cycle 4 till 5, and the smallest being the process P2, so P2 will be given the CPU. P5 will be preempted, that is it will be taken out. That is what we understand by non-cooperating. So between the processes, they will not cooperate with each other, they will interrupt the process which is currently in execution, so it is not able to run till completion. P5 needed 4 clock cycle, but it has been given only 1 clock cycle and it has been replaced by P2 because P2 has the smallest job. So P2 is put in the CPU. Now P2 will run for 1 clock cycle, that is clock cycle 6. Then in clock cycle 6 again there is a comparison between P1, P3 and P5. Now we shifted to clock cycle 7 because in clock cycle 6 if we see the smallest between P1, P3, P5 and P2, smallest between this and the process which is in running is P2 only. So 1, that is why P2 is given one more chance. The burst time is 1 for P2, for P1 it is 5, for P3 it is 8 and for P5 it is 3. So between 3, 8, 1 and 5, 1 is the smallest, so P2 is given the chance. So after this 1 clock cycle 5 till 6, P2 is given the chance till 7. So 2 clock cycle P2 is given the chance to complete his execution because it was having smallest burst time among all the processes available in the system. So P2 has completed his execution. So we have marked it by red. P4 is already completed, and now P2 has completed its execution. Now left is P1, P3, P5. Now again we have to find out between this which has the smallest job. So P1 needs 5, P3 needs 8, and P5 needs 3. So between them the smallest is P5, 3. Between 3, 8 and 5, the smallest being 3, so P5 is put in the CPU. Now as there are no new process in the system, so we need not have to compare the processes which is already available with the process that is currently running. In this case, P5 value will always be smaller as there are no new process entering the system. So that is why P5 will be executed for clock cycle 9 until clock cycle 10, because it has already executed for 1 clock cycle and left was 3 clock cycle, so it will be executed for 7 till 10. I will repeat, from 7 till 8 we did not check in the clock cycle 8, we did not check in the clock cycle 9. The reason being, in clock cycle 8 between P5, P1 and P3 the value of P5 is smaller. Again in clock cycle 9 the value of the burst time between P5, P1 and P3, P5 is the smallest. So between 7 to 8, 8 to 9 and 9 to 10 it remains smallest for P5, so we did not put any other process. So comparison is not required as there are no new processes entering the system. Similarly, after clock cycle 10 we have to see that between P1 and P3, which are the two processes left, which has the smallest job. Now as P1 has already run for 1 clock cycle, that is from clock cycle 3 till 4, the number is 5, that is it needs 5 more clock cycle to complete, and P3 needs 8 clock cycle. So between 8 and 5 the smallest being 5, so P1 is put in the CPU. Now there are no new process in the system, so again comparison is not required. P1 is executed for 5 more clock cycles, so 11 till 15, 10 to 11, 11 to 12, 12 to 13, 13 to 14 and 14 to 15, making it 5 clock cycle, and thus it has completed its execution. Left now is process P3, so it will be executed for the final 8 clock cycle, so 15 plus 8 is 23, so it will be executed for 23 till 23. Hence this is the Gantt chart of the process. So if you see, process P1 is executed from 3 to 4 and 10 to 15. Process P5 is executed from 4 to 5 and 7 to 10. This is because the other process did not cooperate with P5. The other process did not cooperate with P1, so they have to leave the system or leave the CPU in between and give the chance to other processes. So at this point the chance was given to P5, and at this point P5 is taken out and P2 is given the chance. So that is how your preemptive shortest job first algorithm works. Now let us see how to calculate the waiting time. So the formula is simple. Waiting time now is like the previous one, start time minus arrival time, plus this is the additional thing what we have to consider, waiting time for next burst. So let us start with process P4. So P4 starting time, if we see for P4 the starting time was 0, arrival time was also 0, so there is no wait time for next burst, so it is 0. For P1, if we see, the starting time for P1 is 3 and the arrival time of P1 is 2, so 3 minus 2. Start time is 3, arrival time is 2, so 3 minus 2 plus waiting time for next burst. So P1, if you see, this is the one burst it has executed, and then the second chance it has got at this point, that is at this point 10. So from 4 till 10 it has to wait. So this is that waiting time. P1 executed from 3 to 4 and the waiting time 4 till 10 is added. So 4 till 10 is 6 clock cycles. So 3 minus 2 plus 6, that is the value is 7. That is the waiting time for P1 is 7. Similarly, the next process is P2. For P2, start time is 5, arrival time is 5, so we need not have to go for this wait time for next, and it is 0. For P5, the start time is 4, arrival time P5, the arrival time is also 4, so 4 minus 4, and P5, if you see, this is 1 clock cycle it has executed and it is waiting till 5 to 6 and 6 to 7, that is 2 clock cycle P5 is waiting for getting the second chance. So 1 clock cycle and then 2 clock cycles in between, and then again 3 clock cycles. So 3 plus 1 is 4, that is this particular 4 completed, but in between 2 clock cycles, so this is the 2. And the last one is P3. So P3 started at 15, arrived at 1, so 15 minus 1, because it is not waiting or there is no more P3 in the Gantt chart, so 15 minus 1 is 14. So if we calculate, we get 4.6. All the waiting time divided by 5 processes, 4.6. So this is the average waiting time. Try the example given here. Calculate the waiting time for each of the process and also the average waiting time.